Hello, last two problems we'll discuss now. One problem in power in AC circuits, another one for power factor correction. Before discussing about the problem in power, we'll discuss about what is power and what are the types of AC circuits power. We have three types of power in AC circuits. One is real power, which is denoted by P. Another one is reactive power denoted by Q. Another one is the complex power or apparent power denoted by S. S is equal to half VI conjugate, or it can be written as S equal to VRMS into IRMS conjugate. These formulas used to calculate VRMS equal to VM by root 2 or IRMS equal to IM by root 2. And really this P is related to the resistance. Q is related to inductance and capacitance. With this, we'll switch on to the problems. The fourth problem is like this. A circuit is given. In this circuit, we have a source connected to a transmission line modeled with a resistance and inductance, and that transmission line is connected to the load, which has resistance and capacitance. All are connected in series, and the total impedance of the circuit will be addition of all this. What is asked? To find the real power and the reactive power absorbed by all these three: source, line, and the load is asked. To find real power and reactive power, we cannot find it directly. We have to find the complex power. From the complex power, we can calculate the real and reactive power. The real part of the complex power is the real power. The imaginary part of the complex power is the reactive power. From that, we can easily calculate. Now, I have solved this. This is the given problem. Given data is line impedance. Line impedance is this one. Load impedance is this one. Addition of this. VRMS is given directly 220 angle 0. What should we find? To find the source complex power, line complex power, and load complex power, and thereby calculating the real power and reactive power of all these three. So, to know the complex power is real power plus J, reactive power. Impedance is R plus JX. What is this X? X equal to XL minus XC. XL equal to 2 pi FL, XC equal to 1 by 2 pi FC. To find the current, we can calculate using the simple Ohm's law formula Vs by Z. And these things would be known. The unit of real power is watt, unit of reactive power is volt ampere reactive, and unit of complex power is volt ampere. See the difference? VA, VAR, and W. The reactive power has a different case. Reactive power, if the answer is positive, it is lagging power factor. If the reactive power answer is negative, then it means it is leading. Okay, now we'll get into the solution. Now what should we find? We need to find all three complex power. From that we can calculate real and reactive power. For finding complex power, we need Vs and I. Vs is given in the problem. Total Vs is given in the problem 220 angle 0. But we need I. For finding I, we need I is equal to Vs by Z. Vs is known, but Z we don't know. So what is Z? Total impedance of the circuit, which is addition of everything. Addition of everything will get you a rectangular form answer. We have to convert it into polar using calculators. So substituting this Z here, we can calculate I. What we are doing? Substituting Vs and Z. This should be divided. Magnitude should be divided. Angle should be subtracted. So 0 minus of minus 22 will get 22.83. The value will be in RMS. Now we can substitute this I here. See what is the difference? S equal to Vs into I conjugate. What is conjugate? If the answer is like this, I is equal to this one. If we introduce a negative sign for the angle alone, that is conjugate. So see, Vs is taken directly. For I have taken minus sign alone. So that is your conjugate. Multiply this, magnitude should be multiplied and angle should be added. So this is your answer. Convert back into the rectangular form. From this rectangular form, we can calculate P and Q. This is our form P plus JQ. So this is your P or real power. This is your Q or reactive power. Since the answer is negative, it is leading. So I have written here. For line, the same procedure for finding line. Only difference is here we have to calculate V line with different Z. We have calculated voltage and current with overall Z here for the source, but for line we have to calculate the V line using the impedance of the line alone. So Z into I, what is this? It is the impedance of the transmission line which is given in the circuit. See, 4 plus J2 is the transmission line impedance. So I am multiplying that impedance to the current, we are getting V line. From V line we can substitute in S. I conjugate is same because all the impedance are connected in series. So I conjugate into V line, you are getting the answer. Same procedure is used for calculating the load voltage also. Take the impedance of the load alone and calculate VL, change it into polar form and then substitute in SL. SL equal to VL into I conjugate. I conjugate is same. VL substitute it from here. We will get the answer. Convert this polar into rectangular. We are getting 1708 minus J 1139. Here this one is P, this one is your Q. Okay. This is all about the calculation of real and reactive power from the given impedance and the voltage. Next problem is about the power factor. Before getting to power factor, we should know what is power factor. I'll explain you. See, this is power P, this is apparent power. With this P and S, we can calculate power factor. Okay, this is also power, this is also power. Dividing power by power, power factor has no dimension, and power factor can also be calculated using this formula, cosine of the angle between voltage and current. If there is angle difference between voltage and current in the same circuit, then there will be a power factor. If there is no angle, the power factor will become 1. Our aim is to achieve the power factor towards 1. That means the phase difference between voltage and current should be reduced. That is our aim. Okay. How to correct this? If there is many angle, the angle difference between voltage and current is high, it means the power factor is low. So we have to add some capacitance. Okay, that is our power factor correction aim. So here also we are going to do that. In this problem number 5, your actual power factor is given as 0.8 and the real power is given as P is equal to 4000 watt, VRMS is given as 120 volt and frequency is given as 60 Hz. What is asked? You have to increase the power factor to 0.95 from 0.8. Already it is 0.8, we are going to increase it to 0.95. To increase from 0.8 to 0.95, what is the value of capacitance needed? Okay, that is what is asked. For that we have to know what is power factor, what is capacitance. Capacitance can be calculated using this formula, QC divided by omega V square RMS. So what is QC? QC is the difference between Q1 and Q2. Q1 is with respect to 0.8, Q2 with respect to 0.95, that's all, before rising and after rising. Okay. Now what is the formula for calculating Q from apparent power? Q is equal to S into sin theta, P is equal to S into cos theta. We know P, from this we can calculate Q if we know these things, S and sin theta or something. So divide the question into two parts, one is before rising and after rising. Before rising, your cos theta 1 or power factor is 0.8. After raising, it is 0.95. This is what we know. And we know another thing is which is P. P is equal to 4000 is given. So with this, if cos theta 1 equal to 0.8, so theta 1 equal to cos inverse 0.8, which is equal to 36.887 degree. So calculate this theta 1. Here mention is that it is theta 2. So we can easily differentiate. Cos theta equal to 0.95, theta 2 equal to cos inverse 0.95, which is 18.19. Okay. Now substitute in S. S equal to P divided by cos theta 1, which is equal to 4000 divided by 0.8, which is equal to 5000 VA. What is reactive power? Reactive power Q is equal to S into sin theta 1. See, Q1 equal to S1 into sin theta 1. Now we know S1 5000, theta 1 we know 36.87, substitute and find Q1. Likewise, after raising, you will get theta 2, P divided by cos theta 2 equal to 4210.5, and Q2 equal to S2 into sin theta 2. This is theta 2, substitute. What is S2? We have found here Substitute and find Q2. Now there is a difference in Q2. See, the reactive power consumption at 0.8 power factor is 3000. The reactive power consumption at 0.95 power factor is 1314.4. So it is reduced drastically. That difference makes you to find the capacitance value. See, QC is difference of Q1 minus Q2. 3000 minus 1314, which is 1685.6 var. From this we can calculate capacitance. See, capacitance equal to QC divided by omega Vrms square. QC we have found here. Vrms is given. Omega is nothing but 2 pi f. F is given as 50 Hz in the problem, 60 Hz in the problem. So substitute and find C. See, what do you infer from this? This much of capacitance should be connected to the system to increase the power factor from 0.8 to 0.95. This is what is inferred. From this we understood two different things. See, your reactive power is consumption is decreased when the power factor is increased. That is to be noted. Thank you.